So I'll be walking you through the Corrosion CTF, which is a vulnerable machine hosted on the OneHub platform. I'm going to be doing this following a structured methodology, which goes from the discovery to enumeration to foothold and finally the privilege escalation where we gain access as root. We began with the discovery phase where we used Nmap to perform a robust scan, enabling the -S, which is the service detection flag. The service detection flag allows you to see the exact services running behind each of these open ports. Nmap helped us identify that we had the port 22, which is the SSH port open, and also the port 80, which is the HTTP port open. And these are the services running behind them. Now that we know this, went ahead to check out the port 80, and I found out that it was just the default Apache page. This is a screenshot of it. We can then move on to the enumeration phase, whereby we enumerate each of the services we found open. Now, I used a directory brute force tool called GoBuster on the port 80 to help uncover any hidden subdomains, and I was able to find the task subdomain and the blog post. So this is the output of the GoBuster tool hereby. This is the command, and the output showed us that it has the blog post and the task open. These are screenshots of it. This is the task subdomain, and this is the blog post subdomain. I then went ahead to perform further enumeration by performing another directory brute force on the blog posts, whereby I was able to discover the archives and the uploads page. This is the command used. And with this, we're able to see that they had the archives and the uploads accessible to us. Went ahead to visit the upload. This is a screenshot of the uploads. And this is a screenshot of the archives also. While visiting the archives, we saw that there was a file there called randylogs.php. Upon opening the file, it was just an empty file. So I decided to use wforce to test for input parameters that can be leveraged for LFI. LFI is local file inclusion. It's basically a web vulnerability that allows malicious attackers to include or view files on a server by manipulating the input parameters in the URL. So this is the command here. We use the wforce, and we forced for the input parameter here to try and see if we can leverage the input parameter to view the odd.log. And this is the output. With this output here, we're able to see that it has a parameter called file, which allows for the input of the file you want to visit. And with this, we're able to view the auth.log file. Now with this, we know LFI has been confirmed as we've been able to view the auth.log file, leveraging the LFI being found. So this is the content of the auth.log. Now that we've confirmed LFI, we can proceed with foothold. The process I used after confirming the LFI was log poisoning. You can either poison the Apache access log or you poison the auth.log. I poisoned the auth.log using the SSH. So what I did was I basically sent a reverse bash PHP shell in form of a payload via SSH to ensure it gets logged on the web server. So when you rerun the page, it will trigger for a reverse shell to be connected back to an already set listener. So this is the methodology I followed. So upon confirming it that the file parameter allows for us to view the auth.log, I poisoned the auth.log using the netcat by sending the PHP bash reverse shell, which I did using the command here. And this is a screenshot. So basically, netcat, the target IP address, and the 22, you get a banner, and this banner is basically showing you the service version of the SSH port that is open. You then input the PHP reverse shell. So this allows for a reverse shell to be called back to your IP address and on this particular port. Now that I've done this, this attempt will have been logged onto the SSH because it is a failed attempt. It says here invalid SSH identification string. So it will be logged on the all.log as a failed attempt. Upon logging, you can then go to your Metasploit framework. Metasploit framework allows you to automate penetration testing processes from setting up listeners to foothold to privilege escalation. So I used this to set up a listener and ensured the payload was a bash payload because this allows for you to catch a bash shell. I set the local host to my IP and the local port to the same port I put here. Once this was done, I ran it, went back to the page here and reloaded the browser. Upon reload, I was able to catch a shell successfully, but I caught the shell as a limited user, which was www data. This is proof of me catching the shell. It shows that I'm a limited user. That's the www data, which you can see there. This is also here. Now that I've caught the shell, I will go ahead and upgrade the shell to a meterpreter shell for more flexibility. A meterpreter is also a command-like shell, just that it allows for you to run multiple exploits and also has a robust number of commands, which goes from downloading to uploading and from taking screen records. So this is a very powerful shell to do. So that's why I went ahead to upgrade it using the sessions-u flag and the ID of the shell we caught initially. And this is proof of that here. So this shows the ID of the first shell, and using the sessions-u flag, which shows here sessions-u1, you are able to catch a meterpreter shell. Now you have a meterpreter shell. Now that we have the meterpreter shell, we can proceed to the final stage, which is the privilege escalation. So for this, I also used Metasploit as it allowed me automate the escalation process using its post module called the local exploit suggester. This is how the local exploit suggester works. It basically suggests proven escalation paths that can be leveraged to gain root access. It doesn't run them, it only gives you suggestions. It only gives you suggestions that you can use. So with this, I went ahead to use this command whereby I use the post multi-recon local exploit suggester. I set the session ID to the session ID of the meterpreter, which is also being shown here. That's the set session 2. And here you can see it gives us multiple exploits which can be used, with the most promising being the first one, which is the PK exec. PK exec is a vulnerability to the toolkit. Basically, it allows for you to run commands as other users, such as sudo, just that sudo takes its rules from the sudo group, while by PK exec takes its rules from the toolkit. So using this vulnerability, you can leverage it, can be leveraged to get root access by the Metasploit framework. Went ahead to load up the exploits using the use exploit Linux local and the exploit here. You go ahead to set the session ID to the same interpreter session ID, which is session 2, which can be seen here. It sets to session 2. You go ahead and run it. Once you run it, you gain root access, which can be shown here. You can see the server username is being shown as root. Now that you've gained root access, you can go ahead and perform as multiple actions as you want, due to the fact that root is the highest form of privilege available on a Linux machine. Here is a brief summary of the walkthrough, which I did in a tree-like structure, following the same methodology as I discussed earlier. It goes from discovery to enumeration to foothold and finally the privilege escalation. And before I leave for the next capture the flag, I'll be giving you some recommendations. The first recommendation will be for you to always review your web server configurations by regularly inspecting and adding web server settings to prevent path traversal, LFI, or misconfigurations that might lead to file exposure. Also, always sanitize user input. This protects especially against local file inclusion by thoroughly validating and sanitizing all user inputs, especially parameters that interact with file paths. Another one is for you to perform regular audits, patch critical vulnerabilities immediately. In the case of this CTF, I would advise for the concrete version to be immediately upgraded to the latest version to prevent against the exploit of this particular service.